esterification, right? We were doing dehydration. So basically, dehydration is catalytic hydration of inverse of dehydration is inversion of or inverse of catalytic hydration of alkene. From alkene, we prepared alcohol by catalytic hydration in the presence of acid, and dehydration is done by concentrated H2SO4 in the presence of heat. So you will get alkene basically. Okay. So I'm going to show you the mechanism. Very easy it is. Please do write. You are done with up to this, right?
Yes.
Okay. So I'm going to show you. If you have C2H5OH, that is your ethanol, and you are going to use H2SO4 at 443 Kelvin. So you know that C2H5, that means CH2H we can write, and here I can write CH2OH. So what you need to do, just remove this water. And if you are going to remove this water, what you will get? CH2 double bond CH2. Okay, H2O will be eliminated. Okay, so basically in this reaction, there is formation of carbocation. There is formation of carbocation. So I'll show you the mechanism. Before that, I told you formation of carbocation formation. Carbocation formation takes place. That means 3° will be more reactive because 3° carbocation or 3° intermediate is more stable. So if you have secondary alcohol like this, so also you need to apply less temperature like 440 Kelvin, and the concentrated H2SO4 is not necessary. 85% concentrated H2SO4 or 85% H3PO4 if you are going to use, you can get the same result. So you can see there will be CH2 and H, and what you are going to do, you are just going to remove this H2O molecule, this H2O molecule. So what you will get, CH3CH double bond CH2, and H2O will be eliminated. And if you have tertiary alcohol like this, CH3COH, and there is CH3, and there is another CH3. So I'm just going to write CH2OH like this. So the condition you can see is very less. 358 Kelvin only needed because tertiary intermediate or carbocation is very stable, and 20% only H3PO4 is needed. Now what I'm going to do, I'm just going to remove this water molecule again, and what you will get, CH3 C double bond, I'm going to write this the bottom on the right hand side like this, and H2O will be eliminated. Is that clear? So basically from the reaction you can see the relative ease of dehydration, the relative ease of dehydration of alcohols follows the following order. First write it, then I'll show you. Let me know when you are done with this.
Done, sir.
Very good. Now see, follows the following order. Which order I am talking about is very simple. First, it is going to follow tertiary, then secondary, and then primary. And you know the reason. Tertiary carbocation is more stable than secondary and then primary, followed by primary. Then we will talk about mechanism. So write this that we have some washroom. Okay, let's start the mechanism. If there will be question on mechanism, first they ask you to write the mechanism of either ethanol to alkene and alkene to ethanol, and they will give you a question on that mechanism, and it will be under 3 or 4. So basically, step one, first of all, protonation of alcohol will take place. So I'm going to write formation of protonated alcohol. Protonated alcohol. You are going to do protonated alcohol. So ethanol I'm going to take. This is your ethanol. And you know that oxygen has lone pair, right? So this is the scenario. Proton is there. And this reaction is basically fast reaction and reversible. So what will happen? This lone pair will be attacking on this. Okay. So this is what you will get. CC. And there is CH. And there is O. And with O, hydrogen is there already. And this hydrogen will be coming to there. And there will be positive sign because it donated its electron. 2 lone pair was there, so I'm representing it. Now the next. In the next step, formation of carbocation takes place. As you know that positive charge on oxygen is less stable. So what I'm going to do? formation of carbocation. In the next step, formation of carbocation takes place, and it is possible only when carbon is going to take electrons from when oxygen is going to take electrons from carbon. So basically, this second step is the slowest step, and the slowest step is rate determining step. It is the slowest step, and hence the rate determining step, and hence the rate determining step of the reaction. Rate determining step of the reaction stand for reaction. So I'm just going to show you the reaction. I'm just gonna just wait a minute. If I'm just going to take copy and then paste here. Okay, nice. Now see what will happen. As I told you, this will be taking electron from carbon in order to stabilize itself. And this is your slow step. Slow step, that means it will be taking, this will be rate determining step. So we can write CH, H, H, C, H, H. And there is a formation of carbocation, and this becomes H2. Okay, in the last step, I will tell you first right up to this. Let me know when you are done with this. Are you done with this? The first step, are you done with?
Yes, sir.
Okay, so in the final step, what will happen is very simple. Formation of alkene will take place. Formation of alkene, here it will be ethene by elimination of proton. By elimination of proton. Okay. Now you can see this is the scenario. C H, H is there. H is also there. C plus H is there. H is there. So from the adjacent carbon of this carbocation, this bond will be going like this, and it will be converting into C double bond C. H is there. H is also there. H is there. H is there. Ethene. And the H plus that you used in the first step will be eliminated in the last step. So I think it's clear. Second step, are you done with? Please wait for a few minutes. I'm coming. After this, you can do this question. Okay, very good. So, how many isomers if I will be primary? I think, Mom, any answer?
Yes, sir, I said
Oh, Mom, third answer is B. Very good. And fourth answer is first and third reaction. Which of the following reaction can be used for the preparation of alkyl halide? First, second, and third, basically. First, second, and third. You can see anhydrous ZnCl2. That means Lucas reagent, so this will go easily. Tertiary, this is tertiary, so we don't need anhydrous ZnCl2. Third will also go. This is for secondary ZnCl2. So one, third, and fourth. Three answers will be there. Is that clear, Mom?
yes.
Austin, I didn't get any answer from you. Austin is not there. Okay, so actually I was teaching this mechanism. So in the first step, formation of protonated alcohol takes place, and in order to get a stability for oxygen, oxygen will take electrons from carbon, and there will be formation of what? There will be formation of carbocation. After that, formation of ethene will take place by elimination of H plus. Is that clear? This is the mechanism. Both of you done with this? Okay. After this, the next reaction is oxidation. When we are going to oxidize alcohol, what we will get is very simple. So basically, oxidation of alcohol will be taking place by removal of hydrogen. So we can write oxidation of alcohol involves removal of oxidation of alcohol involves formation of carbon oxygen double bond. That means carbonyl, carbon oxygen double bond with with cleavage of an OH bond. You are going to remove OH bond. This hydrogen you are going to remove, and CH, to which OH is connected, you are going to break this, remove this. Okay, let's say if you have an alcohol like this, so this carbon must have hydrogen in order to oxidize this. So this you are going to remove, and this you are going to remove. So you will be getting something like this. Carbonyl you will get either aldehyde or ketone. Please do write it. Now the reagent is very important, which is oxidizing agent, like the reducing agent we studied in aldehyde, ketones, and carboxylic acid in the same. Tomorrow, most probably, this chapter will be completed. Okay, let me send those. This Friday, you will have test up to alcohols and phenols only. Are you done with this?
Yeah.
Okay. So see, for the reaction, let's say this is your primary alcohol. This is your primary alcohol. So if you are going to oxidize this, if oxidation of primary alcohol will take place, you are going to remove this hydrogen and this hydrogen, hydrogen from carbon, hydrogen from oxygen, and you will be getting aldehyde. And if you are again going to oxidize this, or if you are going to use mild oxidizing agent twice, this will be converted into carboxylic acid. Into carboxylic acid. If you are going to use a very strong oxidizing agent, then primary alcohol will be directly converted into carboxylic acid. This is your mild oxidizing agent step. So if you are going to use something like mild oxidizing agent, let's say CH3, CH2OH, CrO3, then this will be directly converting into CH3, CHO, aldehyde. Or you can use PCC as well. PCC is basically pyridinium chlorochromate. If you have something like this and you are going to use PCC, so double bond will be as it is, and this will be converted into aldehyde. So PCC has a full form, pyridinium chlorochromate. Please do that. So primary alcohol will give you aldehyde, and again, if you are going to oxidize it, it will be converted into carboxylic acid. And for secondary alcohol, you will get ketone. There are other reagents which can convert into this. But always remember this, if this carbon is primary or secondary, then it is easy to oxidize. Tertiary carbon does not have any hydrogen. Tertiary carbon, you can see, does not have any hydrogen. So it will not be oxidized, but elimination will take place and alkene will be formed. I will show you. First write it. After this, which chapter we are going to start? Are you done with this? Mom, Austin, why are you not
Yes,
responding?
sir.
Now, if you have secondary alcohol like this, RCHOH and R dash, this is your ketone. So you are going to use this mild oxidizing agent, CrO3. So you can see this hydrogen and this hydrogen will be replaced, eliminated, and it will form ketone. Very simple. After this, we can use copper at a very high temperature, like 300 degrees centigrade. We will get primary alcohol will always give you after oxidation aldehyde. Secondary alcohol will give you ketone, and tertiary alcohol will not give you any ketone or aldehyde. There will be formation of alkene. It will go under dehydration. So we can call this as dehydrogenation as dehydrogenation because hydrogen is removing, eliminating. We are eliminating hydrogen. Now we can use another reagent. Like if you have an alcohol, primary alcohol, and this should be alcohol vapors basically. Alcohol vapors. Why it is so? You know that if you are going to pass this through heated copper at 573 Kelvin, the temperature is very high, more than very more than this boiling point. So it will be converted into aldehyde. And if you have this secondary alcohol with the same reagent, it will be converted into this. That means for primary and secondary, this will be dehydrogenation takes place. Hydrogen you are eliminating, dehydrogenation. But for tertiary, dehydration takes place. But for tertiary, if you are going for this, let's say CH3 is there. I'm gonna make it this side CH3 as well. CH3 is there, OH is there. And if you're going to use heated copper at 573 Kelvin, so basically hydrogen from here and one hydrogen from here, oh, not hydrogen, OH from here and hydrogen from here will be eliminated. And this will be CH3, C double bond, CH2 it becomes, and CH3 there was. So with tertiary, dehydration took place. Very simple it is. Again, the for reaction of phenols, the nitration will come, halogenation will come, bromination. This will be repeated. Only two reactions are there for electrophilic substitution reaction. After that, we will have some reaction like Paul-based reaction, Rimmer-Tiemann reaction, reaction of phenol with zinc dust. That means it will give benzene. Then you have oxidation of phenol. You will get benzoquinone. Let me know when you are done with this. Are you done with this?
Yes, sir.
No. Now moving to the next one, that is reactions of phenols we are going to study. Reactions of phenols. So in reaction of phenols, first we are going to deal with electrophilic aromatic substitution. Electrophilic aromatic substitution. So in this, first we are going to talk about nitration. You know that in nitration we are going to use dilute HNO3. So since we are studying about the phenol, you can see this is the scenario. If you are going to use dilute HNO3 in the presence of H2SO4, there will be formation of an electrophile NO2 plus, and NO2 is there, orthonitrophenol, and then you have paranitrophenol. Tell me which one is more stable, major product and minor product. O means ortho and P means para. You know, orthonitrophenol is more volatile as compared to paranitrophenol. There will be hydrogen bonding in this orthonitrophenol and there will be hydrogen bonding in paranitrophenol as well. But this is your intramolecular hydrogen bonding and this will be your intermolecular hydrogen bonding. I'll show you. And intermolecular hydrogen bonding is stronger than intramolecular hydrogen. Write it. Let me know when you are done with this. Are you done with this?
Yes, sir.
No. So basically, ortho and para these isomers can be separated out. In which form? So we can write this ortho or the ortho and para isomers can be separated by steam distillation. Steam distillation. Orthonitrophenol is a steam volatile due to intramolecular hydrogen. Due to intramolecular H bond. which causes the wait a minute, intramolecular hydrogen bond. Why? Para-nitrophenol is less volatile due to intermolecular hydrogen. Intermolecular H bonding, which causes the association of molecules, which causes the association of molecules. See, intra means in the molecule, there will be hydrogen bonding, and inter means between two molecules. So I'll show you the how the intra and intermolecular hydrogen bonding is taking place, and this isomers can be separated with the help of a steam distillation easily. So first you are going to write this. I'm going to show you. So for intramolecular hydrogen bonding, this is your benzene, and there is OH. OH is like this, and this is your nitrogen like this, double. And there will be hydrogen bonding. This is your intramolecular. You can say this is your O-ortho, O-nitrophenol, intramolecular H bonding. And when we are going to talk about this, you can see, just wait a minute. I need to rotate this. So in the same molecule, if it is taking place, that means it is intra. And if it is taking place like this and double bond, O is there, O is there, another molecule of this will be coming in contact. OH is there. This is your NO2. This is your OH. So what will happen? You can see this will be going in contact with this. So basically, p-nitrophenol intermolecular hydrogen bond techniques. Intermolecular H bond. So very simple it is. Let me know when you're done with this.
Johnson.
Very good. See, if you are going to use dilute HNO3, you will get only one NO2 introduced to either ortho and para, both product you will get. But if you are going to use concentrated HNO3, that means more molecules of HNO3 will be there. So generation of NO2 plus nitronium ion will be more. So in this case, NO2 will be attacking on ortho, para, and again on ortho. And this is called the common IUPAC name 2,4,6 trinitrophenol, or we can call it picric acid. So very simple it is. Nowadays we are not going to use like this. First, what we are going to do, phenol is first treated with concentrated sulfuric acid. Nowadays, this phenol is going to use treat with concentrated H2SO4. So from this you will be getting 2, 4. That means this is your OH. This is 2, 4 disulfonic acid. After this, we are going to use concentrated HNO3. So you will be getting this, which is there, NO2, 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 picric acid. No, let me know when you are done with this. Let me know when you are done with this.
Johnson.
No. After this, in electrophilic substitution reaction, we have another one, that is halogenation, and especially we are going to study bromination, halogenation. So these reactions we already studied. So if you are going to treat this phenol with Br2 in the presence of carbon disulfide in cold or dark, you can say. So there will be generation of an electrophile, that is Br plus, and Br plus will be attacking either at ortho or either at para. Because plus M group, OH is plus M group, that is ortho and para directly. The next one, If you are going to use bromine water on phenol, if you are going to use bromine water or 3Br2, I'm going to write, there will be introduction of 3Br plus at ortho, para, and ortho, and 3HBr will be eliminated. So basically, this is your 2, 4, 6 tribromophenol. Tribromophenol. So when you are going to treatment of phenol with bromine water, we see with bromine water, then what we will get? We will get 2, 4, 6 tribromophenol. Let me know when you are done with this. Are you done with this?
Yes, sir.
Okay. After that, we have the next type of reaction for phenol, and that is always reaction. The name reaction, very important. So basically, what do we do in this name reaction? You are going to treat this phenol with base. Base. So you know that water will be formed. There will be water in the solution now, and phenoxide ion will be formed. After getting phenoxide ion, you are going to treat this with CO2. So and followed by H plus. So CO2 will be introduced on ortho position. It will be like this. And since in the next step you are going to do hydrolysis, H plus is there. So Na will be replaced by H, and there will be formation of C double O negative. So H plus is there, which will convert this into this, which has a name, common IUPAC name, 2-hydroxy benzoic acid, and it has a common name, salicylic acid. So this is the first common name of phenol here. After reaction of phenol with all this, then we will get Rimer-Tiemann reaction. First write it. Let me know when you are done with this. Are you done with this? Mom, Austin. Austin, you are not responding at
Yes,
all in
teacher.
chat box as well. Yes, sir. Now, thank you for the reply. Okay, the third reaction, Raymer Steven reaction. Very important it is also. First, what you are going to do, this is a chemical reaction of phenol. So we are going to take this phenol, and phenol is going to react with chloroform. Phenol, you are going to react this with chloroform in the presence of basic medium. So this is your chloroform in the presence of aqueous NaOH, that means basic medium. So there will be a formation of an intermediate. This is your intermediate. The CaCl2 will be introduced to ortho, and this will be converted into O negative Na plus, phenoxide, phenoxide ion. This is your intermediate. And again, this will be passed through base NaOH. Since it is present in the solution, basic medium it is. So this will be oxidizes into CHO, and O minus Na plus is there. After this, you are going to do acidic hydrolysis. H plus is there. So it becomes OH alcohol phenol here and CHO. So its common name is basically Sally. Just wait a minute. Its common name is basically salicylaldehyde. Attacking reagent is very important. Attacking reagent. Attacking reagent that we get here is dichlorocarbon. Dichlorocarbon. That means CCl2 and dot. This is a this is an electrophile, neutral electrophile, because 6 electron it has. You know how the reaction took place? This Cl basically will be replaced by 2OH like this. I'm going to just explain this. This part, the O negative part will be as it is, phenoxide ion. And this CH is there, and Cl will be replaced by 1OH from the basic medium and 1OH from the basic medium. 2OH on the same carbon is unstable, so you are going to remove water. So what you will get? You will get CHO. You can see O negative will be as it is, Na positive will be as it is. And here what you can see, C hydrogen is there, oxygen is there, so double bond will come. This is most important. The intermediate attacking reagent is your dichlorocarbon. Please do write. Like intermediate during reaction mechanism, you have seen free radical, you have seen carbocation in the same way. There is another intermediate that is called carbene. There is other intermediate like carbon ion, carbene, nitrene, benzene. Lots of other reactions of the intermediate. Let me know when you are done with this. Let me know when you are done with this. Are you done with this?
Done.
Okay. Hey, next section is very important. That is reactions of phenol with zinc dust. Like if you are going to react this phenol with zinc dust, zinc will reduce this. Zn will take oxygen and hydrogen will be with this ring, so it becomes zinc. Sorry, benzene, and Zn will be out. The last reaction of this phenol is oxidation. This is the fourth reaction of phenol. Now, this is your oxidation. And in oxidation, when you are going to use Na2Cr2O7, sodium dichromate, in the presence of H2SO4, this will be oxidized into ketone. diketone basically. It lost its aromaticity as well. And this is your benzoquinone. Are you done with this? Mom.
Yes, sir.
Okay, so there is a homework for you, additional from my side. This is your homework. There is some theoretical things that you need to write a note about this from NCRT, and that is your some commercial. You just need to write it and read it and note it, whatever is important for you. Commercially important alcohols. I think a one page is there. You need to write about methanol and ethanol. So write whatever is important for you. I need it by Thursday, Wednesday night, tomorrow night. Okay.
So, sir, I can't submit by Wednesday.
When can you submit? Thursday?
I'll submit before the next class.
Before the next class is on Thursday.
Okay, I mean the next week class.
Oh, next week.
So I
Okay.
have exams and I'm going to Makkah Medina. That's
Okay. 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 Then next week you are going to submit. Is there any problem for you, Austin? Oh, please do submit. Okay. Now we are going to talk about ether. Ether, you already know what is ether. ROR. So directly we are going to talk about its preparation of ether. You know the reagent that we use to prepare alcohol, we are going to use the same. Sorry, the reagent that we used on alcohol to get alkene, it will be same in ether by dehydration of alcohols. Only minor difference will be there. Only minor difference will be there. I'm going to show you. The both reaction is given in NCRT if you're going to see. Ethanol is there. And if you're going to use H2SO4, in both the method, we use H2SO4. Only the difference is that here the temperature is to form alkene 443 Kelvin, and here the temperature is 413 Kelvin. Here you will get CH2 dehydration will take place. And here you will get CH3, CH2, O, CH2, CH3, ethoxyethane, CH3. So write it. I'll show you the mechanism how this ether forms. Very simple it is. The first step is similar to the alkene one. Both of you are done with this. Mom.
Yes, sir.
Okay. So this is also three-step reaction. And very easy it is. First, protonation will take place as in the case of alkene, formation of alkene. This is your protonation. You know that oxygen has lone pair. So this oxygen is going to attack on this proton. So what you will get, you will directly get CH3, CH2 and OH. Oxygen will have positive charge and one lone pair left. After this, in the next step, you are going to take another mole of this. See, this is the difference. In dehydration of alcohol to get alkene, only one mole of alcohol we take, but for the formation of ether, you are going to take 2 moles of alcohol. So see, this is the scenario. We are going to take another mole of this alcohol, and this that we protonated alcohol, we are going to take CH3, CH2. And you can see O will have positive charge. This is the scenario. O will have one lone pair. So positive charge on oxygen is very less stable. So oxygen will take electron from this carbon. Now this carbon will be filling some deficiency of electrons. So this oxygen, this alcohol will be attacking on this. So what will form? I'm going to write this one first. CH3, CH2, and then oxygen attacked. Oxygen has one hydrogen. Since oxygen donated electrons, so it will have positive charge and one lone pair left. And the rest part is on the left hand side, CH2, CH3. Is that clear? This is the first
Yes.
step, protonated alcohol, then alcohol attacked on that. Formation of carbocation forms before that this attacks. And you can see there is dehydration of alcohol. That means in the second step, you removed water molecule. Now, in the last step, you can see again oxygen has positive charge, which is unstable for oxygen, unstability for oxygen. So, in order to get a stability, what will oxygen do? It will take electron from hydrogen and it becomes CH3, CH2, OCH2, CH3. This is the mechanism. So, please do write it. I think in the next book only we have biomolecules left, right? This book, second book. Yes or no?
Yes.
First, I will send you the biomolecules notes and then I will explain it. You can write it or take the printout. Very easy it is. The reactions will be also there. Let me know when you are done.
Done, sir.
Yeah. So in the next class, we are going to complete this chapter. Can you again please tell me? I'll make this list. Biomolecules we are done with. We need to do. Chemical kinetics we need to do. Any other chapter? D and F block. Chemical kinetics we have already done, right?
Yes, sir.
So tell me any other chapter that is left. Electrochemistry. We are done with solution. Surface chemistry. Austin, please help us. And Umami, you too. Any other chapter, Austin? D and F block is in the syllabus, right? Okay. Any other chapter? So in the next class, we are going to complete this chapter and start amines. Amines is left. I forgot. Actually, it is in another batch. Okay, Huma.
Okay, sir.
Any other chapter that is left?
No, sir.
Okay, then. I'll see you in the next class. Thank you.
Sir,
Yes.
could you show the homework part again? I will take screenshot.